So you finished creating your custom PCB and now it needs some way of living wherever it's going to live. And a lot of the time you're going to want to have a project box like this for it to live in. And this is one that I have quickly 3D modeled and 3D printed for a specific PCB that I've just finished designing. And you can knock these up really quickly and it's pretty simple to do. And I'm going to show you how to take a finished PCB design that I've created in KiCad and then use Fusion360 to make a custom perfectly sized project box for it with a couple of considerations that you need to think about when making these things. So let's have a look at the PCB first. This is what I've created. What it doesn't really matter at this point, but it's an automotive PCB and you're going to see this in a bit more detail in one of my future videos. And if we take a look at the 3D view, it looks like this. So it's just got a few components and a space where an ESP32 is going to plonk itself down on the top of this board. And I want to create a box for this to live in. And I've already made the holes in the corners where it can attach and secure itself in the box. And we're going to need to consider where wires come in and out. Now, if you have a PCB that's like just to hand, let's say this thing here, which is just like a voltage step-down modulator, you might have to get a ruler out and measure it and figure out where all the points are. But when you've got a KiCad model like this, the easiest thing you can do is just export a step file. And the step file is a 3D model file. So if we take that and we go onto my desktop, we call it ESP32 large, that's fine. Export that step file. And then that is, you can't see it because it's off screen, but that is now on my desktop. So if we get rid of this and bring in Fusion360, obviously you have lots of options for 3D CAD programs that you can use. I've used Fusion360 for a long time. Very familiar with it, and it's my go-to for use. Anyway, let's import our model. So we're going to just file, open, and then find on our desktop that step file. And when we open that, we'll have a 3D model of our board ready to go. And this works as a great blueprint for modeling off because it makes things really easy. It's already completely 100% to scale. So if we take our measure tool at the top here and go from side to side, it should be 92 millimeters. And as you can see, 92 millimeters. So I'm going to use this as a template in order to create our custom project box. And I'll show you a few considerations that you need to think about when creating them in general and also when creating them for automotive use, because there's a couple of like things here and there that you need to consider. But what we want to do is start on probably the back face of this because it's nice and flat. What we want is a box with a lid that we can drop the unit into, and then we can attach the unit into the base so it doesn't rattle around and it doesn't hit any of the sides. It needs to have enough padding around the outside edge for potentially wires, because these holes along both sides are the basic pinouts, and we might need to run a few wires down the side. We also need to make sure that any impact, top, bottom, and sides isn't going to hit the PCB itself. And we also need to think about anything that maybe gets a little bit hot, so potentially this buck converter just stays away from being right up against the sides. So we'll kick things off on the back, and if we click on the back face here and then go to create sketch, we'll be able to access like all of the details of the back face because they're included in the sketch because we're sketching onto that plane. It's going to make life a lot easier. There's a few ways we can make a box. I like to use offset, so this offset sketch generation. And if we click on the outside edge, we can then create an offset of a certain width that goes all the way around. Now you might think, oh, I only need to give it 1 millimeter just to give it a little bit of padding space, but there are other couple of considerations that we're going to need down the line when it involves the lid plus the routing of wires. It means it's generally better to go a little bit bigger and give it a little bit of breathing space. So I'm just going to give it a 5 millimeter gap all the way around the outside edge. Then I'll click offset again and do another one, which is 7mm, which leaves me with this 2mm outside edge, which is going to be my outer wall. So while I've got this outer edge selected, I can click on E for extrude, and that will give me the option up or down to create like walls. We need to make sure that it goes up high enough to at least go over the top of the highest component. And if you click on a wall or a face, it'll basically extend up to that point. So if I clicked on there, it would go, okay, well, that's 6mm. There is 9. Generally speaking, if you're going to be 3D printing this, you're probably going to want to keep it in relatively whole numbers. Really, I do slices of 0.2mm. So I know that if I give my sizes, especially with the height when I'm thinking about how it's going to slice, if I do everything in 0.2s, it's not going to have any problems like splitting the layers. So it's 9.5 minimum, plus I've got to consider there's going to be an ESP on top of this. So I'm going to give it 14, just to give it a little bit of space on the top. Then I can go to one side down here and go to 2 sides, and then we can bring the bottom down. And then the bottom's going to have to cover those pins that fall out the bottom there. And that gets covered at 1.5. So let's go down to 3, so -3. So again, nice whole numbers. So -14, -3. Okay. And there is our outside walls. So then we want to put a bottom on this thing. And one of the easiest ways is just to click that outside edge again, extrude it by the thickness that we want the bottom to be, which is going to be 2mm, and then do that as a new body. So when we're on the extrude options, change that to new body, and then take one of these edges, so that one, the inside edge, again extrude and select the opposite edge, which will fill in that bottom bit. But because these two pieces are also touching and we're in the join operation, it'll merge everything together like that. So yeah, if you didn't want the side and the bottom to merge at that point, if I just undo that, you click on this side and you extrude it out to that side. This is going to merge everything because they're all touching. But if you basically in our bodies here, if you hid that top body and then did it, and then brought the body back, you'd still have them as 2 separate pieces, which you could then later combine with this combine tool, bum, bum, and it would do the same thing. But otherwise, it's going to do it in one go. So there's our kind of like outside of the box. Now I've got these 4 mounting holes, which are the places where I want to put screws through to hold it onto the board. So I need to make like 4 little towers that will hold this up to stop it hitting the bottom of the board. So let's name this as base and then hide it. And again, I'm going to start on the bottom layer here, create the sketch, and I want to create like a tower that's on each one of these 4 corner points. And it's dead easy to do. You can do it one of 2 ways. You could either just click on here and create an offset by whatever amount that you want, say 2mm, just to give it a slightly wider pillar. Or we could just take the circle in the inside of the circle and set the circle to say 6mm, which is probably going to be about the same. I'm just going to do the 6 because I think it's a little bit quicker. 6, 6, 6, and 6. So we've got 4 little towers here. What I'm going to do is just take all of those parts, so the inside and the outside. And bear in mind, at the moment, we're drawing this on the bottom plane here. So this is, when we press E to extrude and bring it down, these are basically going up to the bottom of the board. So that's where it's going to sit on. So if I show the base, you notice when you start to extrude, it shows it full. But when you get it to a point where it's interacting with the base, it turns red. It's because it thinks you automatically want to cut out, which you can see over here. But we don't, we want to join. So if we join that, and then click OK, when I hide the base, this base here, we'll see we've got these now 4 little towers. and they're all part of that same base model. But obviously it doesn't just sit on top, we want to screw it into place. Now Fusion360 does allow you to create threads for screws, but generally speaking for something like this you're not going to need to do it. I use quite fine 2.5mm diameter screws, and these holes, if we look and click on one of those, you'll see the edge diameter down the bottom is 3mm. So it fits through there nicely, but it needs something to grab on the bottom. And one of the things with 3D printing is you can just basically make the hole ever so slightly smaller than the screw, and it'll kind of self-tap into that hole, which will be more than sufficient for this. So we'll go on to basically this plane again. I've pressed C there to create a circle, and I'm going to create a 2.2mm circle because I want it to be a little bit smaller than my 2.5mm wide screw. I'm just going to do that on all four corners again. 2, 1, 2, and I'm holding shift and just clicking the inside edges to select them all. And then press E to extrude again, but this time we're going to pull it downwards so that if we clicked on the bottom, it would be 3mm. And yeah, that's probably fine because it's going to be 3mm plus the thickness of the board itself, which is 1.6. So that'd be 4.6mm. Maybe want to go a little bit more, so -4. That'll be fine. We've got this 2mm base, so there's still an extra millimeter gap at the bottom. All good. So there's our four corners. Now, if you really wanted, if you did have a certain thread that you wanted to use and you wanted to model that in, you could totally do that by going to Create Thread here, and then click on the inside, choose the thread that you want. So if I was going to be doing a 2.5mm screw, pick a 2.5. It's probably going to be an M designation because in Europe everything is M designation that we buy. And then you actually click in Modeled here, and you'll see, if we zoom in, it will model in that thread, and that would actually print in. But because of the way this is 3D printed, there will be layers there anyway, so it will naturally like grab onto those layers. You need to make sure that it's not too big of a difference because it will just split the 3D print, but using a 2.2mm hole for a 2.5mm screw is going to be fine. So that's the base of our box roughly done. Let's add a lid on it, and again it's pretty easy. We'll just take this outside edge again, extrude it, and we'll extrude it by 2mm as we did last time, not 23, 2, and do a new body. So this new body here is going to be our lid. And then similarly, let's, like I showed you earlier, get the base hidden so that when we extrude this to here to fill it in, it doesn't join up to the base. Then we'll hide the lid, show the base. And we want to just make a way of it not rattling around. So if I start a sketch on this top piece again, and I use the offset like we did before, and click on the inside edge, I can make an offset that comes just inside. So let's say 0.4mm, which will give me this plane here. And then if I bring that down -1, maybe just 1mm will be fine. It'll give us this little lip that just drops inside the box. Then I can take the lid, if I hide the base, and combine the lid with the lower part of the lid and just join. We don't need to keep the components or keep the tools or anything. We end up with this whole piece of the lid. And as you can see, if I click M and then click on the lid, you see how it moves. And that just kind of like slots in, and you can imagine that little lip just stops it rattling around. But it needs to be secured. And you could just do it like this and then wrap it up with some tape or a strap or something, I don't know. But what we want to do is secure it down properly with some screws, because this is going to be an automotive application, so we want to make sure it is done properly. So just hide the lid. And one of the reasons that we gave ourselves all that extra space around the outside edge was because of this lid. So if I'm going to show the base, I'm going to click on the bottom, so the inside bottom of the base, and then press C, which is going to start a new sketch again, put me in circle mode, choose the corner, and see how big of a diameter it can go to without it touching or being too close to the corner of the PCB. Somewhere around 12 looks about right. So we'll do that in all four corners. 12, 12, 12, and 12. Then I can take those four inner corner segments and extrude them up to the point where they hit the bottom of that inner lip there. So it's going to be 16 millimeters. And I just need to make sure I hide the lid, otherwise it's going to join the lid and these pillars up. Then show the base, and that'll make these part of that base. There we go. So the base now has these four corner parts on it. Then I'm going to need to put some holes in these and matching holes in the lid where the screws can go through. So let's hide the lid, and I want to make sure they're like evenly distributed in these four corners, and you can't really, there's no midpoints or anything to do that. So if we start a sketch based on this top edge again, so I'm going to start a sketch there, use the offset of the inner edge, and then just decide where I want the center of that circle to be. So maybe 2.4. Might be too far in, might be too far out, but we can adjust it afterwards. It's one of the advantages of using Fusion. So if I press C, or press circle here, we can create our screw holes again, and then we're going to use the exact same screws. So 2.2 for a 2.5 millimeter screw. So C 2.2 and C 2.2. So what I said about the adjustments is if you thought, okay, actually this isn't in the center, it happens that it is and it looks good. We could take that 2.4 millimeters from the edge here and change that to say 2, and everything would shift outwards or inwards. 2.8 would bring it in, and all four of them would adjust together. Just makes life a little bit easier, but 2.4 happened to be bang on. So now I can get rid of that box. So double click on it, press delete. And let's just take these 4, 3, and 4. So we'll extrude downwards again. So E to extrude, pull down, and you'll see it goes red, which means it starts cutting. We'll go in 8 millimeters, which will be fine. And then do 2 sides and pull the top all the way up. Show the lid. And there we go, holes cut in the lid. One of the small extra little bits I want to do though is make sure that the screws that I use can recess so they're not protruding from this lid. It's a small benefit, but I just like it aesthetically. So I'm going to draw on this top plane, press C, and make it say 4 millimeters. So 4 millimeter circles all around here. 4, 4, 4, 4. Select those circles again. In fact, you could just select the outside ring here. So 1, 2, 3, and 4. E to extrude, minus the depth that I want it, so 1.5 millimeters. 1.5, actually 1.4, because I want to be in units of 0.2. So 1.4. That gives us a nice little recess, which should be great. So with that made, that's the majority of your box. That's a good base point. So we've got this lid, click M, and see it's going to come up, and so it'll just attach and then screw down, and this unit will all be screwed down too. But we've got to consider where the wires are going to come in and out, and that's going to vary project to project. So now I can save this, use this as a baseboard to do any design that I want when I'm using this board, and I'm going to be using this board for a lot of projects that we've got coming up going forwards. But on a case-by-case basis, I need to consider what wires are going to come out, what one's going to win, where it's going to be positioned in the car, etc. This first version is actually going to be going in the boot of my car under where the spare wheel is for now, and control the underglow of my car. So I know that because of the design of my board, which I just pull back up here, we've got the wires that come in and out for the power here. We've got the 12 volt that goes out here, which is what runs off to my lights. Plus I need a data port for the 5 volt data control signal for my lights. So that'll be, because this is on this side, I'm going to pull one of these and just run it out with it. So one of these will be the output pin. Doesn't really matter which one at this point. So I'm going to be running power cables in here and power cables out here. I could bundle them all together, but I'm actually going to be using 2 different terminal clips at the end, like a 2 and a 3. So I'll just run the wires out separately. So we can just do that. If we click on this inner wall and press C, it'll show us that wall, but we can't see it because we're on the outside of the box. If we use this tool up here to spin around and click on the edge, it'll give us a 45-degree parametric view. So if I make sure I'm in circle, I can then kind of just get it in the middle of these two. So this is where our input's going to be for these 2 wires. And you see a little auto snap to the middle. So let's go there and make this hole 6 millimeters. I think that's probably big enough. And then we'll do the same over here. We'll do another one. So C in the middle of there. Oh, it's not snapping anymore. Then we'll just create a center line and then do another one on that line. So another 6. So we've got these 2 spots where the wires are going to be going out. Just grab those, E to extrude, bam, and there. So that's where our wires are going to be coming in and out of this box. Obviously, in different circumstances, sometimes you're going to want wires to come in one side and out the other. Sometimes it's not going to matter. It's all going to be deterministic based on where it's going to be mounted in the car. And one of the last things we need to consider is, how is it going to be mounted in the car? Is it going to be strapped to something? Is it going to be using double-sided adhesive? Is it going to be glued to something? There's obviously a lot of options, and depending on how it's going to be done, depends on if you need to create like mounting points for it, because you could do it inside the box, but generally speaking, I think doing it outside is a little bit easier. So we're not going to actually use some on this, because this one is just, it affixes to a metal panel in the boot. It doesn't get screwed down. It just gets some double-sided 3M and it gets stuck down in the boot. That's absolutely fine. But just in this example of how we might go about creating a mounting point, if that's what you wanted to do, is if we go onto the bottom of the box and create a new sketch, we go into the middle. So the middle is here. So if I press L, we'll snap to the middle. And it's just going to make ourselves a couple of like sticky out middle bits. So my screw that I would mount this with would be, let's say, a 3mm self-tapper. So I need to ensure the hole is a little bit bigger than that, because it doesn't need to self-tap the 3D print, it just needs to self-tap the thing behind it. So if we know that the hole is going to be 3.5mm, it needs to be at least half of that away from the box, just to give it space. So if we actually just use the diameter as the distance away the middle is, we know we've got space. So if I just click here and go along there for 3.5, oh, 3.5, then press C and give ourselves 3.5, we're definitely going to have that clearance here that we need. And I'll click on this again, C, and then make it bigger with like enough space and clearance around it. So 10, I think 10 is a good number. Then I'm going to press L for line, go from the middle to the top and then back. So create a few like little lines. So from the center to the edge, from the edge and then in, which gives us all of these little bits here that we can grab. So we'll take all of those bits and then E to extrude, then move it up on the other side. So if we give it, you know, make it reasonably thick, so -4 millimeters. And again, we might just want to give ourselves a little bit of space for the top bit to like recess. So we'll click on the top, I'm going to press C for circle in the middle, and then again, let's make this 5.5, no, 6 for the big head of the screw, -2. And there we've got the space where our screw will sit. So then we can very quickly do the exact same thing on the other side. So if you remember the process, we just pressed L, create a line. The center was 3.5 away, so 3.5. C for circle, make a 3.5 circle, like that. Then make another circle, which was 10. Then add the lines that allow us to like join everything together. So line to there, line to there. And this is why you do that line, because usually it doesn't know where the bottom edge is. So you're just basically telling it where that bottom edge is, like that. Grab these parts, 1, 2, 3, 4, all those parts. Extrude by -4. Click on that. C. Center. 6. Click on that, and then -E, -2. There we go. So then we have two kind of like mounting holes on the side that we can use in order to mount it. And then if we decided, oh, that's actually a little bit close to the box, you could grab the majority of the edges like this. If you hold shift and grab all of those, then click M, you could just move it all out, make it bigger and smaller as you need. So we could say, okay, actually I want it 2 millimeters further out. And there you go. That would just do that. Which is nice, actually. Yeah, let's do that on both sides. So hold shift, click all the faces, M, move it out too. General rule is if you're trying to move stuff like that, you need to click at least 50% of the faces that you're planning to move, and then some it'll move because the other things around it are moving, so they have to move. And yeah, that is our finished project box. So this one, funny enough, is the exact same as this one, because this is one I've just made. And so this is kind of what the bottom comes out like, and the top is printing right now. So these are just now waiting for the PCBs. They are on the way from PCB Way, who I'm working with, who have sponsored me for the next series of these videos where we're finishing up this kind of whole interactive internal car thing that isn't really relevant to this video, but you'll see it in future ones. And then we can actually get everything installed and put in the car. And that is a video that is hopefully going to happen very soon, because this is the end of a series on a custom wireless underglow controller that I've been creating. And then I have a big series which is going to be using a bunch of these PCBs and a whole load of these different 3D printed project boxes in order to create a brand new center console and replace all the gauges with new modern touchscreen things. It's going to be weird and wild. It's going to be really cool. I'm looking forward to that. Oh, and one thing about these, ABS. So ABS is my go-to for printing these because it's strong, it's heat resistant, and it doesn't crack super easily. Like when you've got them with a good infill percentage, these are, you know, decently strong. And yeah, the big thing is they're not going to melt if you get them hot in the car. So don't use PLA if you're going to use anything in a car. ABS or ASA, or maybe SLA if you've got a fancy SLA printer. I use ABS because it prints really easily and it does everything that I need it to do. If you've got any questions about creating these project boxes or Fusion in general, I know Fusion very, very well, just let me know in the comments and I'll see what I can do to help you out. Otherwise, whatever you do with the rest of your day, folks, have a wicked one, and I will see you in the next video for all the awesome stuff that's coming. Take it easy, peeps. Bye-bye.